My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. This is episode number 30 of the 120 Days to Jamb Chemistry with Flash Isaac. In this episode, I shall be doing justice to acids, bases, and salts. Acids, bases, and salts in one video. Now, if I ask my 10-year-old sister, what is an acid? And she says, an acid is a substance which when dissolved in water produces hydrogen ion. I will forgive her. But at your age, if I ask you, what is an acid? And you say that an acid is a substance which when dissolved in water produces hydrogen ion, I will not forgive you. And if I ask you, what is a base? And you tell me that a base is a substance which when dissolved in water produces hydrogen ion, I will flog you. Do you know why? There are levels to things. When it comes to acids and bases, we have three theories. We have how many theories? Three. We have acids theory or definition according to Svante Arrhenius around 1884. We have the Jonas Bronsted and Thomas Lowry theory or definition of acids 1923. Then we have the G.N. Lewis theory of the acid. So, if I ask you, what is an acid? You give me any of these definitions. You say, according to Arrhenius, or according to Bronsted and Lowry, or according to G.N. Lewis, an acid is dash. According to Svante Arrhenius, an acid is a substance which when dissolved in water produces hydrogen ion. And a base is any substance which when dissolved in water produces hydrogen ion. Hydrogen ion is a positive ion, that is H plus. So, how is hydrogen ion formed? Hydrogen ion is formed when hydrogen atom gives out one electron. Hydrogen atom has one proton and one electron in the outermost shell. So, if hydrogen atom gives out the only electron it has, it simply means that it doesn't have electron anymore, only proton is remaining. So, hydrogen ion is referred to as proton. Now, let's see this substance, HCl aqueous. Aqueous simply means in solution or dissolved in water. Anytime in chemistry you are balancing an equation or you are given a chemical equation and you see under aqueous, it means aqueous. It means this substance is in solution, it dissolves in water. By the way, acid is from the Latin word acidus, which means sour. Acid has a sour taste and acid is corrosive. Bases, on the other hand, they have bitter taste and they feel slippery and soapy. These are the basic physical properties of acids and bases. Both acids and bases can change the colors of indicators, which we can see very, very soon. And they have their chemical properties or their reaction, which we shall also look at. What happens when this HCl dissolves in water? HCl aqueous simply means HCl in water, and it is different from HCl gas. HCl gas is hydrogen chloride. HCl aqueous is hydrochloric acid. If this guy dissolves in water, we'll have H plus aqueous plus Cl minus. What has happened? An acid or this substance has dissolved in water to form hydrogen ion as the only positive ion. Then the other ion is a negative ion, which is chlorine ion. Therefore, according to Arrhenius, this is an acid. Now, acid contains hydrogen. According to Arrhenius, acid must contain hydrogen because for you to give out hydrogen ion, it means you have an acid. And according to Arrhenius, bases are substances which, when dissolved in water, aqueous solution of sodium hydroxide will give you hydroxy ion, OH minus aqueous plus sodium ion, aqueous. According to Arrhenius, bases are substances which, when dissolved in water, produces hydroxy ion as the only negative ion. The other ion is positive. So, according to Arrhenius, a base must have hydroxy ion and acid must have hydrogen ion. But is this always true? No. There are acids that don't have hydrogen ion and there are bases that don't have hydroxy ion. So, if they don't have all those things, how will they be able to give out the hydrogen ion? We shall see that soon. But look at this. Since this base has hydroxy, OH, and acid have hydrogen, why is it that when acid dissolves in water, it chooses to give out hydrogen ion? And why is it that when Arrhenius bases dissolve in water, they choose to give out hydroxy ion? This is it. Acids, according to Arrhenius, they have hydrogen, but they don't need this hydrogen. Take a look at water, for example, H2O. This is water in bond like this. Water is V-shaped or bend shaped. Since oxygen is more electronegative than hydrogen in water, oxygen will tend to pull more of the electron to itself, which means there is equal sharing of electrons in water, which leads to distortion and polarity. Therefore, water has the positive side and the negative side. As the oxygen tends to pull more electrons to itself, oxygen becomes partially negative. And as hydrogen is getting less of the electron, hydrogen becomes partially positive. This is what happens in water. Now, acids are substances that normally they don't like hydrogen and they don't like hydrogen. They want to take hydrogen away, which means acids are substances that chooses to lose hydrogen ion. Bases are substances that choose to lose hydroxy ion. They don't want it. Take a look at it this way. In school, we have Mr. A who doesn't like girls, no women. I don't want to marry. I want to remain single. And we have Mrs. B, girl, who wants to date every guy around, right? And we have Mr. C, who wants to marry and settle down. Eventually, this Mrs. B is taking around Mr. A. That's what girls do. They like people that don't care about them. The ones that give them attention, they don't take those ones serious. So this guy is not really ready to settle down, to marry. He wants to be single. But this girl who wants to be around every guy is with this guy. So this guy will be playing along, going out with the girl. But if this guy sees somebody who is interested in the girl, this guy will want to give out the girl. So let's call this guy acid. Let's call the girl hydrogen. The hydrogen ion in the acid, because acids contain hydrogen ion according to Arrhenius. Let's call C base or any substance that is willing to receive hydrogen. So if this happens, this acid will be willing to give out the hydrogen ion. Now you ask a question, why is the acid willing to give out the hydrogen ion? This is what happens. Hydrogen ion is simply a hydrogen atom that has lost electron. So an acid wants to give out the hydrogen ion because immediately the hydrogen ion goes, the acid will receive electron. So acid takes electron from hydrogen and say get out. So acid has benefited. Not just the fact that acid want to give out hydrogen ion. No, acid has something to gain. If this HCl, if this hydrogen goes to form this hydrogen ion, you notice that the acid has received electron, or the chlorine has gotten electron. So it receives electron by letting the hydrogen go. Hydrogen is happy to go, then chlorine is happy to receive the electron. Therefore, acid is a substance which, when dissolved in water, produces hydrogen ion as the only positive ion according to Arrhenius, and basis is any substance which, when dissolved in water, produces hydrogen ion. Now look at something else. Hydrogen ion cannot exist. Hydrogen ion does not exist in water or in solution. The hydrogen ion produced will react with water to form H3O, hydronium ion. So, acid being a substance which, when dissolved in water to produce hydrogen ion, is wrong, or is not totally correct, because the hydrogen ion produced, there is no way it will exist on its own or in solution. The hydrogen ion will always react with water to produce H3O, which is hydronium ion. Now look at the equation for hydrogen ion plus water to form hydronium ion. Now look at something very, very important. When an acid reacts with base, salt and water is formed. That process is referred to as neutralization. In this case, if this hydrogen acid produces hydrogen ion and base produces hydrogen ion, there is chance that this hydrogen ion and hydrogen ion will combine to form water. While the chlorine ion plus sodium ion will combine to form salt, sodium chloride. That is the basis of neutralization. The H plus and OH fuse together to form H2O. And if it is only acid dissociating in solution, the H plus reacts with water to form hydronium ion. Now let's look at Bronsted and Lowry acid. According to Bronsted and Lowry, an acid is a proton donor, while a base is a proton acceptor. Now, what is proton? That is simply hydrogen ion, which means, according to Bronsted and Lowry, so long you can donate proton, you are an acid. So long you can accept proton, you are a base. So you do not need to have hydrogen ion or hydrogen ion to be termed as acid or as base. For example, ammonia is a base, but it does not have OH, which means if we are following the Arrhenius definition, there is no way we will call ammonia a base. So back to this. If this is HCl and this is H2O, what happens? The HCl has donated hydrogen to water to form H3O, and the water has received hydrogen ion from the acid. Therefore, here, this is the proton donor. It has donated hydrogen ion. So, this what is remaining is Cl minus. Now, this is water. Water has accepted proton, proton acceptor. So, after accepting the proton, it becomes H3O plus. According to Bronsted and Lowry, water is a base. HCl is an acid. Now look at HCl aqueous plus ammonia. HCl donates proton to ammonia. Ammonia becomes NH4 because the hydrogen ion has increased. Ammonia accepts proton to be this. Now after donating proton, HCl becomes Cl minus. Now take note of this. Acids increase the hydrogen ion concentration in a solution. In any solution, acids will tend to increase the hydrogen ion concentration, while bases will tend to increase the hydrogen ion concentration. For example, when water dissociates H2O, you have H plus and OH, which means the solution will already have hydrogen ion and hydrogen ion. Water, acids, will tend to increase that hydrogen ion present by dissociating or adding hydrogen ion, which is according to Arrhenius. Then bases will tend to increase the hydroxy ion concentration of a solution. There is something referred to as conjugate acid and conjugate base. Conjugate acid and conjugate base. If, according to Bronsted and Lowry, acids are proton donor and bases are proton acceptor, when an acid donates a proton, what is remaining is a conjugate base. When a base accepts a proton, the result is conjugate acid. Look at this. This is an acid, HCl. It donates proton to water. After donating proton, what is remaining in the acid is Cl minus. So this Cl minus is conjugate base. Now, this is proton acceptor. This base or water accepts proton. After accepting proton, the result is H3O plus, and this is referred to as conjugate acid. Now, in summary, conjugate base relates to acid. When an acid donates a proton, what is remaining is conjugate base. And when a base accepts a proton, what the result is conjugate acid. So, in this case, H2SO4 donates a proton to water. Water becomes H3O, and what is remaining in the acid is HSO4 minus. Here, this is the conjugate base because it is what is left after an acid H2SO4 has donated a proton. Now, water has received a proton. The result is H3O plus. So this is conjugate acid. For something like this, HClO4, if this acid donates a proton, the conjugate base will be ClO4 minus. If HCl donates a proton, the conjugate base of HCl is Cl minus. The conjugate base of H2SO4 is HSO4 minus. It has two protons. When it donates one, this is the conjugate base. If nitric acid donates a proton, what is left is NO3 minus. This is the conjugate base. If hydronium ion donates a proton, it will be left, it will turn to water. Now, if water donates a proton, water will be left with OH minus. Water is amphoteric. Water can act as both acid and base. Water can act as both Bronsted and Lowry acids and Bronsted and Lowry base. For example, in this case, water is accepting a proton to give us hydronium ion. Now here, water is acting as an acid by donating a proton to give us OH minus. According to G.N. Lewis, acids are electron pair acceptor, while bases are electron pair donor, which means any species that is deficient of electron, that doesn't have much electron, will tend to accept electron. Now, anyone that has more electron or excess electron will tend to donate electron. Now, for positive ions, they represent the guys that have donated electron. Remember, when a substance or an element or a compound gives out electron, it becomes positively charged. And when an element or a substance accepts electron, it becomes negative charged. Therefore, H plus, K plus, SO2, Cu2 plus, Fe3 plus, these guys, they already gave out their electron before. Now, they don't have much electron. They will be ready to accept electron. Therefore, since they are electron pair acceptors, they are Lewis acids. So if you see all those species with plus positive ions, they are likely going to be Lewis acids. Now all these guys, OH minus, F minus, H2O, NH3, Cn minus, these guys, they have electrons because they already received electron. And since they have received electron, it is easy for them to give out the electron. So electron pair donors are Lewis base. So these are examples of Lewis base, examples of Lewis acid. These are examples of Bronsted and Lowry acid, HCl, HNO3, H3O plus, H2O. The Lewis base H2O, and NH3. Arenous acid, HCl, HCN, H2SO4. Arenous acid must have H. The arenous base must have OH, NaOH, KOH, CaOH2. Acids, in terms of strength, can be strong acid or weak acid. Strong acid, when they dissolve in solution, they dissociate completely, they ionize completely, they give out all their hydrogen ions. Therefore, we say that that is a strong acid. For weak acid, they dissociate partially. When dissolved in water, they don't give out all their hydrogen ion, they partially dissociate. So, examples of strong acid are hydrochloric acid, nitric acid like HNO3, then H2SO4 is a strong acid. HClO4 is a strong acid. These are major strong acids. They dissociate completely in solution. Then weak acids are H2CO3 is a weak acid. It does not dissociate completely in solution. H3PO4 is a weak acid. CH3COOH is a weak acid. Weak bases are the ones that when dissolved in solution, they don't dissociate completely. While for strong bases, they dissociate completely in solution. A good example of strong base is NaOH is a very strong base. Meanwhile, ammonia is a weak base. In terms of how many acid that is present in water, acid can be concentrated or dilute. Before then, you don't pour water inside acid. There will be explosion. You pour acid inside water. A concentrated acid is an acid that has more of the acid than water. You have small water, you pour a lot of acid on it. That is a concentrated solution or concentrated acid. A dilute acid is the one that you have a lot of water, many water, plenty of water, you just drop small acid in the water. Acid is present in the water, but it is not very concentrated or in large quantity. Something else you should know about acid is basicity of acid. Basicity of acid is the number of replaceable hydrogen ion present in an acid. Remember, acids, they contain hydrogen ion. How many of these hydrogen ions are replaceable? That is the basicity of the acid. For example, hydrochloric acid has one hydrogen, and in solution, the hydrogen ion can be replaced. It can give us the only hydrogen ion it has. So which means the basicity of HCl is 1. For H2SO4, it can give us 2 hydrogen ions. 2 of its hydrogen ions are replaceable. Therefore, the basicity is 2. For H3PO4, it can give us the 3 hydrogen ions. So the basicity is 3. For ethanoic acid, CH3COO4, although it has 4 hydrogen, only 1 is replaceable. Only this particular one is replaceable. So the basicity of ethanoic acid is 1. This is ethanoic acid or oxalic acid. We can replace this and this. So 2 hydrogen ions are replaceable there. So the basicity is 2. Take note of these acids and their basicity. They are the ones Jamb wants you to know, and they are the hotkey ones. Basicity is the number of replaceable hydrogen ions present in an acid. We also have acidity. Acidity is the number of replaceable hydroxy ion present in a base. For NaOH, the acidity is 1 because it has only 1 hydroxy ion and it is replaceable. For KOH, the acidity is 1. For AgOH, the acidity is 1. For CaOH2, the acidity is 2. This is slaked lime. It has OH times 2. So the 2 can be replaced. So the acidity is 2. For MgOH2, the acidity is 2. For AlOH3, since there is 3 here and OH, the acidity is 3. This takes us to the common acids and their uses. Common bases and their uses. HCl, hydrochloric acid, is used to remove rust from iron, used to remove rust from iron. H2SO4 tetraoxosulfate acid is used as a drying agent, it is used as a dehydrating agent, and it is used as electrolyte in lead acid accumulator. Let me analyze. Drying is the removal of water from a substance, and dehydration is the removal of the elements of water from a substance. If you remove water molecules from a substance, you are drying. But if you are removing the elements of water like hydrogen ion and hydroxy ion from a solution or from a substance, you are dehydrating. And dehydrating will alter the structure of that substance. H2SO4 can be used for the both. An electrolyte is a substance which, when direct current is applied through it, it dissociates to conduct. So it conducts when it is in molten state or when it is in solution. Gases have different drying agents. You don't just dry gases up and down, you use agents to dry gases. Like we already established, H2SO4 is a drying agent. What is H2SO4 used to dry? H2SO4 can be used to dry all gases except ammonia and hydrogen sulfide. H2SO4 can be used to dry all gases except ammonia and hydrogen sulfide. Now, fused calcium chloride is a drying agent, CaCl2. What is calcium chloride used to dry? Calcium chloride is used to dry all gases except ammonia. All gases except ammonia. Then quicklime, CaO, is referred to as quicklime. Quicklime is specifically designed to dry ammonia. So if you are asked which of the following is used to dry ammonia and you see quicklime, it is correct. Now, P2O3 phosphorus oxide is used to dry all gases also except ammonia. Meanwhile, silica gel is used to dry all gases, whether ammonia, hydrogen sulfide, whatever, it is used to dry all gases. So these are drying agents and the gases that they are used to dry. Remember, I said that in terms of physical properties, acids, they have sour taste, acids are corrosive, acids, obviously they have pH less than 7 because pH less than 7 is acidic, then from 7 to 14 is basic. That means bases have pH greater than 7, basics are bitter, they have bitter taste, they are slippery or soapy feel. HNO3 is used to make fertilizers and they are used as explosives. Citric acid is from lemon and lime. They are used to make fruit juice. Acetic acid is from vinegar and ethanoic acid and they are used as preservatives and as for dyeing. Boric acids are used as antiseptic or germicide to kill germs. Tartaric acid is used in baking, is used to make soft drinks, and it's used to make health salts. Fatty acids are from fat and oil. They are used in soap manufacture. This takes us to bases and their uses. Before we look at bases and their uses, let's see indicators. Physical properties of both acids and bases is that they change color depending on the indicator. The major indicators are methyl orange, phenolphthalein, methyl red, and litmus. In acidic medium, methyl orange will be red. So when you put methyl orange in a substance and it turns red, that shows that that is an acid. In basic medium, methyl orange is yellow. Phenolphthalein in acidic medium is colorless, and in base it is pink. So the presence of pink color of phenolphthalein shows that base is present. Colorless in acid shows that phenolphthalein is used and acid is present. In methyl red is red in acid and it is yellow in base. While acid turn litmus paper red and bases turn litmus paper blue. These are the indicators used for acids and bases. Sodium hydroxide is a base. It is used for soap making and to manufacture plastics. Potassium hydroxide is a base. It is used for soap making and dyeing or electroplating. However, while sodium hydroxide is used to make hard soap, potassium hydroxide is used to make liquid soap. If you can't see the video very well, increase your resolution. This is a 1080p video and it is clear as recorded. Slate lime is used to make mortar, cement and whitewash. It is also used for liming. Liming has to do with neutralizing acid soil. Ammonia is used for bleaching clothes and it is used as detergent. Then aluminium hydroxide is used for as mordants in drying. Mordants, they help dyes to stick to clothes. So AlO2 is used as mordant in dye. Now, let's take a look at chemical properties and preparation of acids and bases. Now, a popular chemical property of acid is neutralization. When acids react with bases, they form salt and water. Acids react with triazocarbonate 4 to give you salt, water, and carbon dioxide. For example, when an acid reacts with Na2CO3, that is triazocarbonate, let's say HCl, you form the salt, sodium chloride, water is formed, and carbon dioxide is formed. So, acids react with triazocarbonate 4 to give you salt, water, and carbon dioxide. When acids react with metal, they give you salt and hydrogen. If HCl reacts with sodium, that will give you sodium chloride and hydrogen will be given off. So, most metals will displace hydrogen from acids. Therefore, bases, the first chemical property of base is neutralization. Base reacts with acid to give us salt and water. The decomposition of ammonium salts is a property of base. When ammonium salts react with alkali, they give you salt, water, and ammonia. So to get ammonia from ammonium salts, you add alkalis. Alkalis are soluble bases. Quicklime is a soluble base. Sodium hydroxide is a soluble base. So any soluble base is referred to as alkali. And group 1 elements are referred to as alkali metals, probably because their base form, they are soluble in water. They give rise to production of soluble bases. Preparation of acids. We can prepare acid by direct combination of elements. If hydrogen reacts with chlorine in the presence of electric spark or activated charcoal, you form hydrochloric acid, aqueous. When sulfur reacts with oxygen, you form sulfur 4 oxide. This sulfur 4 oxide reacts with oxygen again to form SO3. Then SO3 reacts with water, or in the presence of water will give you H2SO4, which is an acid. Acid can be formed when acid and hydrides dissolve in water. Acid and hydrides are oxides, non-metallic oxides that dissolve in water to form acid. Examples are SO3, CO2, and NO2. These guys, they dissolve in water to form acid. SO3 plus water gives you H2SO4. CO2 plus water gives you H2CO3. NO2 plus water gives you HNO2 plus HNO3. Now take note of something. NO2, nitrogen 4 oxide, dissolves in water to give us two acids, HNO2 and HNO3. Therefore, NO2 is referred to as mixed anhydride or mixed acid anhydride, since it dissolves in water to give us two acids. And acid can be prepared by action of acid on the salt of another acid. H2SO4 is an acid. Sodium chloride is a salt formed from another acid. If both of them react, which means acid and salt can give you another acid. That is These are the ways we prepare acids. And for bases, we can prepare base by direct combination, which means sodium plus O2 give you 2NO2O, calcium plus oxygen give you calcium oxide, calcium plus oxygen give you calcium oxide as well. Now, if this sodium oxide dissolves in water, it will give you sodium hydroxide, a base. If this calcium oxide dissolves in water, it will give you calcium hydroxide. And if CaO, this is potassium rather, potassium hydroxide dissolved in water will give you 2KOH, and calcium oxide dissolved in water will give you calcium hydroxide. That is slaked lime. So one of the guys here should be potassium. We can prepare base by a reaction of metals with steam or water. If sodium reacts with water, we get sodium hydroxide and hydrogen. A base has been prepared. Calcium dissolves in water to give us calcium oxide, calcium hydroxide and water. A base is prepared. We can prepare bases by heating carbonates. Once you heat CaCO3, calcium triazocarbonate, you form calcium oxide and carbon dioxide. A base is prepared. Bases can be formed by action of alkalis on salt. When soluble bases react with salt, generally they will give rise to the formation of a base. Ladies and gentlemen, acids and bases. We've done so much on the acids and bases. Can we look at salts? Yes, salt is simply an interesting and a straightforward concept. Look at this. We said that according to Arrhenius, acids are substances which when dissolved in water produces hydrogen ion, which means every acid will possess hydrogen ion according to Arrhenius, and bases will possess hydroxy ion according to Arrhenius. And we also explained the basicity of an acid. We said that it is simply the number of replaceable hydrogen ion present in an acid. And we said that acidity is the number of replaceable hydroxy ion present in a base. Now, since acid contains replaceable hydrogen ion, if some or all of these replaceable hydrogen ion present in an acid is replaced by a metal, the result is salt. So, when the hydrogen in an acid is replaced totally or partially by a metal, what is formed is salt. Look at this. This is H2SO4 plus copper. This is a metal. What happened? This hydrogen ion, the two replaceable hydrogen ion in H2SO4 are replaced by a metal to form CuSO4 and water. So acids react with metal to form the metallic CuSO4 and water. This is a normal salt. Why? All the replaceable hydrogen ions present have been replaced. So for a normal salt, the pH is 7. It is neutral. It is not acidic or basic. Examples of normal salts are sodium chloride, zinc sulfate, and nitrate, KNO3. On the other hand, if only some of the replaceable hydrogen ions in an acid is replaced by a metal, which means hydrogen ion is still remaining, the acid formed is acid salt. The salt formed rather is acid salt. Look at this. H2SO4 reacts with sodium hydroxide, which is strong acid and base. What happens? In the solution or in the result, we have NaHSO4 and we have H2O, which means although we have two replaceable hydrogen ions in this acid, only one is being replaced by a metal. One remains. So salt containing hydrogen is an acid salt. Examples are KHSO4, NaH2PO4, CaHPO4. Now, if this were to be complete neutralization, if both of them were replaced, we'll have Na2SO4 and water. In that case, it will be normal. Basic salt, on the other hand, is when all the hydroxy ion present in a base are not replaced by a metal. Only few of the hydroxy ion present are replaced. Look at this. This is slaked lime. reacting with acid, what is formed? Acid and base. We are now forming salt and water, but this salt still contains hydroxy ion, so this is a basic salt. Any salt containing OH is a basic salt. Examples are this and this guy. Now double salts are alums. Double salts are alums. They contain two different positive ions. For example, this is a salt containing potassium sulfate and aluminum sulfate. When you have dot in the salt, it is likely going to be double salt. So this is potassium alum, this is aluminum alum, KAlSO4 2.12H2O. This is a double salt. Potassium is a metal, aluminum is a metal. Potassium is a metal, aluminum is a metal. So two salts combining, they give you that double film. Or alums, these are double salts. A complex salt is a salt containing complex ions. For example, potassium hexacyanoferric ion, sodium tetrahydrozincate. All these guys, they are complex salts. This contains the complex ion ZnOH. This contains the complex ion Fe. And remember, formation of complex ion is a property of transition metal generally. And to prepare salt, we choose two methods, whether we need to prepare soluble salts or insoluble salts. To prepare soluble salt, neutralization, acid reacting with base, the salt form will be soluble. When acid reacts with metals, hydrogen is displaced and salt is formed. The salt form is soluble. When acid reacts with carbonates, the salt form is soluble. Meanwhile, to prepare insoluble salt, you use direct combination. If you combine iron and chlorine, you form iron chloride. This is insoluble. Then silver nitrate reacting with salt, sodium chloride, to give you silver chloride and NaNO3. Silver chloride is an insoluble salt. Iron chloride FeCl3 is an insoluble salt. And this takes us to properties of salts. The three major properties of salts are efflorescence, deliquescence, and hygroscopy. Efflorescence is a phenomenon where a salt containing water of crystallization. These are water unique to salt molecules to keep the molecules together moving. When you see a compound with .5H2O, .10H2O, .24H2O, all these are water of crystallization. Now, if these salts containing water of crystallization are exposed to the atmosphere, they can lose some or all of their water of crystallization. When they lose some of the water of crystallization, they form lower hydrates, which means if you have 10 and you lose 5, you'll be left with 5. So you are forming lower hydrates. If you lose everything, you are forming anhydrous salt. So Na2CO3.10H2O is washing soda. When washing soda loses all its water of crystallization, that is efflorescence, it forms soda ash. This is CuSO4.5H2O. So efflorescence is a phenomenon where when exposed to the atmosphere, a salt loses some or all of its water of crystallization to form lower hydrates or anhydrous salt. And deliquescence is a phenomenon where when a salt is exposed to the atmosphere, it absorbs moisture onto a point where it becomes a solution. Absorb moisture, then it dissolves, it forms a solution. Deliquescent salts are sodium hydroxide, iron FeCl3, KOH, CaCl2, that is calcium chloride. They are deliquescent. Now, hygroscopic salts are salts that, when exposed to the atmosphere, they absorb moisture. These ones can even absorb water because they turn to solution. But hygroscopic salts, they absorb moisture, but they don't turn to solution. They don't dissolve. So, quicklime, calcium oxide, copper oxide, NaNO3 are hygroscopic salts. And hygroscopic salts generally are used as drying agents. Then, the concept of pH. pH stands for potency of hydrogen or power of hydrogen. pOH stands for potency of hydroxy or power of hydroxy. The pH scale, we have from 7 is the middle, we have 14, we have 1. So the pH scale is from 1 to 14. From 1 to 6 is acidic. From 8 to 14 is basic. Any substance with pH of 7 is neither acidic nor basic, it is neutral. Like normal salt, we have a pH of 7. Now water on itself, we have a pH of 7. Now, as you go from 8 to 14, pH increases, basicity increases, which means a substance with pH of 13 is more basic than the one with pH of 8, because as the bigger the values for bases, the bigger the base it is. But for acid, as you go this way, a substance with pH of 3 is more acidic than the one with pH of 6. So for acid, smaller values represent higher pH. And for any calculation under pH, pH is negative log of hydrogen ion concentration. If you are given hydrogen ion concentration, pH is the negative log. The good news for Jamb is that the hydrogen ion concentration you get most times are something like this. Let's say 1 times 10 to the power of minus 4. If you are given hydrogen ion concentration to be 1 times 10 to the power of minus 4, the pH is negative log of 1 times 10 to the power of minus 4, and that is 4. So long here is 1. If here is 1 and you have times 10 to the power of minus something, the pH is the something. So if hydrogen ion concentration is 1 times 10 to the power of minus 8, the pH is 8. No need to say, how do I use calculator to solve for pH? How do I calculate? No. If the hydrogen ion concentration is 1 times 10 to the power of minus 7, no, 1 times 10 to the power of minus 4, 1 times 10 to the power of minus 3, the pH is 3. 1 times 10 to the power of minus 2, the pH is 2. Now, what if it is not 1 times something? Let's say it is 2 times 10 to the power of minus 4. Then pOH is negative log of hydroxy ion concentration. Negative log of OH minus. That is pOH. Then pH plus pOH is 14. If you are given pOH and you are asked to look for pH, simply subtract 14 from the pOH. If you are given pH and you are asked to look for pOH, simply subtract 14 from the pH. And hydrogen ion concentration times hydroxy ion concentration is equals 1 times 10 to the power of minus 14. These are useful formulas for pH calculations. And let's look at this question under Flashlearners Jamb application. We are given hydrogen chloride, hydrochloric acid dissolved in water to form hydronium ion and chlorine ion. In the reaction above, Cl- is dash. After hydrogen chloride, hydrochloric acid has donated proton, what is remaining is Cl-. So that is conjugate base. What is left after an acid has donated proton? Ethanoic acid is dash. A. Tribasic. B. Unioizable. C. Monobasic. And D. Dibasic. Ethanoic acid is CH3COOH. It has 4 hydrogen ions. These 3 will not give out. Only this one is replaceable. So ethanoic acid is monobasic. Ladies and gentlemen, I have 101 questions under acids, bases, salts, and pH in the Flashlearners Jamb application. I've given you everything you need. If I start answering questions and all the questions, we'll do only acid, bases, and salts. Then we'll get to 120th episode. We need to cover everything. So your own assignment for your own good right now, if you've not installed the Flashlearners Jamb app, install it using the link in the YouTube description, or visit flashlearners.com to install, or on your Play Store search Flashlearners Jamb app, or chat me right now for installation guide and activation. When you get the app, open it, go to practice for UTME, then click chemistry. Under chemistry, choose random under here, and under topic choose acid, bases, and salt. Click on pH, then you continue. With that, questions will be shown under acids, basic, salts, and pH. Play with them, answer them, enjoy. The more you practice, the more you are used to question, the more your confidence will boost. If now you are still scared of Jamb, you are depressed, It shows that you've not really have that confidence, you've not played the question. So do that. And if you have any problem with any of assignments I give you, always reach out to me. I will guide you. My own is to help you. To whom much is given, much is expected. So I don't expect to see more for something that is for your benefit. I don't sleep. I sleepless night, prepare, record, edit, upload, spend money to make sure you learn. If on your part you are not ready to make sacrifices, we move. Alright, see you in the next episode where we shall be dealing with Broders reaction, oxidation, and reduction.